We need to check the convergence of the given series. For given series, suppose summation an is given. So for this series, an is equal to n square r- into 2 raised to the power minus 2n. So we have few tests to check the convergence of the given series. First is a very common test, ratio test, and the second one is root test, which is oftentimes frequently used root test, and the last one is limit test. So what are these tests? In ratio test we find limit n tends to infinity an upon an plus 1 if this limit is equal to n, and I am saying if L is greater than 1 then the series convergent. If L less than 1 then series divergent, and test to fail at L equal to 1. In root test, the limit an raised to the power 1 upon n is equal to L. If this limit is equal to L, then series will converge when L less than 1, series will divergent when L greater than 1, and test fail at L equal to 1. And what limit test says, if limit of an is not equal to 0, then I can say series is divergent, and these three tests are applicable for positive term series. So we have root test and ratio test, and which one is more beneficial to check the convergence of the series? Whenever, as it is given, an 2 raised to the power n, not 2 raised to the power n square into 2 raised to the power minus n. Whenever n is involved in the power, so many times you should to apply root test, because in root test we need to compute limit of this expression, and this 1 by n cancel out the power as given in the an term. So root test is more powerful than ratio test because we can easily predict the convergence of some series using root test, but ratio test failed to predict the convergence of the series. So we are checking the convergence of the given series. So I'm going to apply ratio test, sorry, root test. So need to compute limit n tends to infinity a n raised to the power 1 upon n, and an is n square into 2 raised to the power minus n raised to the power 1 upon n, and we need to take limit n tends to infinity. So as I can apply limit f into z equal to limit f into limit z, using this fact I can write limit n tends to infinity n square raised to the power 1 upon n into limit n tends to infinity 2 raised to the power minus n upon n. So what we have, I can write limit n raised to the power 1 upon n whole square into limit 2 raised to the power minus 1, and this is constant, so limit is same. So this limit will be 1 upon 2, because 2 inverse is 1 upon 2 multiplicative inverse of this one, and we know that this limit is equal to 1, so 1 is square. So what we have 1 into half, and this one is equal to half, which is less than 1. So by the root test I can say this series is convergent.